Yeah, come on. Now read it slowly and loudly so everybody can hear it.
An object in motion.
An object in motion with constant velocity, yes,
Remains in motion.
unless
Acted
upon by
a
force.
external force.
Right. So what that second portion of it is saying is, hey dude, we can be in translational equilibrium. So an object moving can still be in equilibrium. It does not have to be at rest. In this class, where everything's at rest. This building has a bazillion forces and moments on it. We ain't moving. Right? It's not spinning, it's not translating, it's just stationary. That's the first part of Newton's first law. Now, all that mumbo jumbo, all of what he said, turns out from an equation perspective, what? Sum of all the forces is equal to 0. Go ahead. Tell me you need a cheat sheet. Seriously? Law of sines, law of cosines, sum of forces equals 0. That's it. Nothing else. Do you really need a cheat sheet for that? Do I need to look that up somehow, some way? No, you can memorize that. Now, first part of the chapter is 2D equilibrium. The second part of the chapter is 3D equilibrium. 2D equilibrium says, hey, sum of the forces in the x equals 0, sum of the forces in the y equals 0. That's what it says. So, in the first part of the chapter, you have 2 equations of equilibrium. Hopefully you're solving for 2 unknowns. If you have more than 2 unknowns, you better add some equations. Well, what type of equations could be added? The answer is 1, Hooke's law. What does Hooke's law say? Hooke's law for springs, what does it say? Yes? Raise your hand loud. Yeah, there you go. Higher. Yeah. Big crowd. What does it say? You? KX. Hey, you guys are changing shit on me. You got a second law coming in, you're saying QX? Yeah, okay, thanks for testing me. So F equals KX. K is known as the stiffness parameter. It's basically the proportionality factor that relates F and K, F and X. And what is X? What is X? Yes. Yes. It's not the length of the spring, it's how much have you deformed it from its initial length. So if it's 10 feet, right, and you deform it, then it goes to 12 feet, how much is X? 2. It's the amount of deformation. Now, here's the best part. I can arrange springs in series and in parallel. And if you're looking at test questions, you will see me throw them in series and in parallel all over the place. Now, there are 3 things you should know about springs in series and 3 things you should know about springs in parallel. Let's start with, I don't know. What do you want to start with? Series or parallel? Series. My man wants to start with series. Tell me one fact. Remember, there are 3 facts for series, 3 facts for parallel that you must know. Give me one for series. The K values add up, he says. How many agree with it? You agree with it. Springs in series, the K values add up, true or false? And you wonder how I get my true-false questions. Here's one right now. We just did it. What did you say? False. She says false. Okay, we're on this side of campus. I know it's pink one day, blue the next, and then shades of gray in between. And you write an essay and you justify the, your bullshit. You can't bullshit this. You can't bullshit this. Is she right? What'd she say? What did she say? So if it's false, then, so I've got one person that says, hey, just add up the case. She says, no, wrong. Okay, so if it's wrong, what is it? Hairdo man. Hairdo man doesn't know. What's your last name? What? Underhill. Oh, bearded one. Yeah. Yes. 1 over K1 plus 1 over K2 plus 1 over K3 is equal to 1 over K equal to it. So it's not just the sum. What would be the sum? Parallel, correct. In another fact I should know when it comes to springs and series. Huh? Yeah, displacements are additive. So if I have one spring and it has a deformation x1 and another one x2 and they're in series, I can bring them together and say x equivalent is x1 plus x2. What's the third fact I should know about springs in series? Yes. Common force. What's your last name? Gardner. What do you like to do, Gardner? Not Gardner. What do you like to do? You like to read. What kind of reading? Sci-fi. Okay. True or false? Nora likes to read sci-fi.
False.
That's good. Because that's very much true. Everybody heard everything about series? Yes? Now somebody tell me about parallel. You got the case. Very good. Hey, you learned something already. You know what? You're never going to forget this now. You're not. That's why I ask these questions, because you'll remember that shit. Tell me something else about springs and parallel. Not you.
The forces add.
What?
The forces add.
The forces add. Is that true?
True.
What do you know about displacements? They're the same. They're the same. If you don't know those three things by the test time comes around, you're screwed. You're screwed. It's that simple. You got to know it by the time the test goes around. Testing manual, anybody. She's got it. Okay. Now we just went over stuff about springs and parallel springs and series, correct? All right. By the way, we just covered all of this mumbo jumbo. These are things that you would see in the video. Okay? Let's see here. Okay. Let's just open up test 1. Oh, holy shit. What the hell do I see here? 1, 2, 3 springs in parallel. K1 plus K2 plus K3 equals K equivalent. Forces are the same, and the displacements are the same, and the forces are added. Bing, bing, bing. Done, done, done. That is one test question. Question number 2. Oh, shit. 2 in parallel, 1 in series combined to that. And you're looking at it going, wait a second. I don't have anything like this in the damn textbook. You're right. Just like You won't have textbook problems when you go out there in the real world, would you? I seriously doubt it. So get used to it. You have to become the solution maker. Not ChatGPT, not Chegg. You are the solution maker. Okay? You with me? So I'm giving you examples of what's going to happen to you. Then I see pulleys. Oh shit, pulleys. If you saw the video, you know something about pulleys. What do you know about pulleys? Give me 3 things you know about pulleys. 1. Frictionless. Weightless. And the cable that it wraps around the pulley is 50-cent word, inextensible, which means it ain't stretching. 3 things you should know about a pulley. Now, because we call it frictionless, what do I know about the tension on the left and on the right side of the pulley? So pretend there's a pulley here. Here's one force, here's the other force. What do I know about them?
They're equal.
They're equal. They're one and the same. Now, if there's friction in the pulley, they ain't equal. As a matter of fact, we're going to keep them equal until we get to the friction chapter. We're going to say, hey, by the way, the real world, there's friction. In which case we say, one side is T1, the other side is T2, and we relate the two by the belt friction equation. T2 equals T1e to the mu beta. But that's not here for now, that's a later thing. What does it mean to be weightless? There is no such animal as a weightless pulley. But we're saying, hey, the weight of the pulley is 10 pounds, but it's carrying 5,000 pounds. 5,000 to 10, negligible. That's what you're really saying. Could I take into account the weight of the pulley? Absolutely, and I will show you. Okay? You with me? So, pulleys. Oh shit, there's pulleys here. We're going to do a problem today and show you how to deal with pulleys. From this point forward, you'll be able to do any pulley problem I gave you on the test. Okay? Now, the first part of the chapter I told you was all about 2D. Well, in 2D, for every free body diagram you draw, 2 equations. Some force X, some force Y. Some force X, some force Y. It doesn't change. Okay? What are you going to be solving? Well, there's really 4 types of problems you're going to solve. Here they are. They want you to calculate the magnitude of a particular force, F1, and the direction of F1. So F1, theta 1 could be the 2 unknowns. It could be that you're asked to find F1 and F2. 2 forces. It could be you're asked to find a theta 1, theta 2. 2 angles. Or it could be you're asked to find a force of one and the angle of another. That's it. Break it down. It's very basic, very simple. Those are the 4 possible scenarios of you calculating equilibrium of 2D. That's it. It won't be any different. Okay? You with me? Who's not with me? All right. Let's do a problem or 2 or 3, however many we can get in before the end of the. Whose book was this? I believe. What did you see in the test question? What did you see? You saw pulleys. You saw springs in parallel, springs in series. You saw a block on an incline, right? Blah, 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 correct? So, if you look closely, oh, there's a pulley problem. is a block on an incline problem. So I'm going to show you these, and then on the test, I'm going to jumble them up all together and throw it at you. That's what's going to happen. Okay? If you look at the front cover of your Pro Copy booklet, you can see a question number 2. These are all old questions from old tests. What do you see here? 2 springs in parallel. How do I change that? Add K1 plus K2. Give me 1 single spring. That 1 single spring now is in series with this spring. How do I deal with that? 1 over K1 plus 1 over K2 plus 1 over K3 plus 1 over K4 plus 1 over K5, blah, 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 equals 1 over K equivalent. Which means I can replace all 3 springs by uno. By 1. Well, guess what? That's exactly what you see here. 1 spring attached to a block. Well, when I do the K equivalents, I'll have 1 spring attached to a block on an incline. Yes? Perfect. All right. So I'm not hiding anything from you is what I'm trying to tell you. Here we go. Page 33. What's the first thing we need to do? First thing we need to do. Huh? Free body diagram. Well, before I draw the free body diagram, first thing I need to do is... That would be helpful. But if I don't even read the problem, what's the first thing I want to do?
Identify your forces.
Huh?
Identify your forces.
No.
Check the coordinates.
No. There is no fucking coordinate system. Yes! Find the freaking point of concurrency. I don't need to read the question to find the point of concurrency. I actually have 2 of them. And I usually circle the point of concurrency. Wherever my circle touches a cable, a rod, whatever, I then have to show that in a free body diagram. So the first thing I do is I find the point of concurrency. I don't need to read the question to find the point of concurrency. And it doesn't matter where the problem is, I will always find a point of concurrency. Okay? All right. Once I've found and circled the point of concurrency anywhere my pen touched, I have to show as a force. Notice it touched here, here, and here. Here, here, and here. So those black dots have to be shown as forces on a free body diagram. Now, before I go into my free body diagram, I now will read the question. It says, given the system shown, and knowing that the weight D, or the weight hanging at D is 300 pounds. So I've been given some information. This is 300. And notice what I do right away. I put the value next to the damn thing. Okay? What else do I do? Oh, by the way, the tension in BC is 241. So I'm going to put the damn thing right here, 241. Is there anything else I know? No. Because then it says, hey, tell me all the forces and all the cables and the angle theta. Oh, okay. So I found the point of concurrency, I read the question, put in any info on my diagram, such as the 300 and 241. Now I'm ready to draw my free body diagrams. Free body diagram. Here we go. Free body diagram at the point of concurrency, at D. And I'm going to draw a free body diagram at B. Easy peasy. Here we go. I got 300 down. I got a cable tension going this way, TBD. I got a cable tension here, TDE. Notice the 3 black dots have now been represented as cable tensions or as forces in my free body diagram. Agreed? This is not that hard. Next thing I'm going to do is I'm going to put a coordinate system. The beauty of this class is we only use one coordinate system. And that's the XY. That's it. We don't use any other coordinate system. How many going on to dynamic switch? In the first chapter, we use 4 different coordinate systems. 1, 2, 3, 4, 4 of them. Just in one chapter. Yeah. It sucks. Next, I'm going to add the angles here. This is 45. This is 30. If you don't know how I got those 45 and 30, raise your hand, please. Because I will move on, because that's geometry. That's got nothing to do with stats. If you don't, raise your hand so I can go over it. Otherwise, I'm moving on. You, carpenter, what don't you know about this? I pulled it out of my ass. Isn't that great? I made this shit up. But I made the right one up. So I'm going to draw a line right here. I'm going to draw a line right here. I'm going to draw this line right there. 2 parallel lines, that's the transversal. That's 45, that has to be 45. Alternate interior angles are congruent, like your geometry teacher said. Remember that? That's why I did it. Same thing with the other one. If that's 60 here, that has to be 30. If that's the transversal, that has to be 30 because alternate interior angles. Yes? Who's not with me? You with me now, Carpy? She's with me. Okay. I'm going to go to B, and I'm going to draw the free body diagram of B. I'm going to show this cable tension, TDB. It's the same one I drew over here. I'm going to show this one, which I already know is 241. And I know this cable tension, TBA, and that's theta. Drawing my coordinate system. Here's my Y, here's my X. Great. Do not write any equations until you've drawn free body diagrams. Did everybody hear that? This is your accounting ledger. Because what you see is what you're going to write in equation format. Before you start writing equations, I'm going to ask this simple question, and you should ask the simple question too. Hey, which freaking free body diagram should I start writing equations first for? Should I start at writing free body diagrams at B, or should I start at D? That's the question of the day. Where do I start? Now, you can start writing right away. Some force X, some force Y, some force X, some force Y. But there's an ideal place to start, and there's a non-ideal place. Which is the ideal place to start? D or B, and don't just float out B, D. After you blurt it out, I want to know why. Because if you know why, you're now being educated. You're not just guessing. I think it's D. I think it's B. What?
D?
D.
Is there more?
What?
No, it's like.
Yeah, I got it.
We have 2 angles in D.
I got 2 angles at D.
Those have a weight, so we can find.
I have a weight. Got it so far. You still haven't explained shit to me. Because you've explained the obvious. I got angles, I got weight. Yes, that's where I'm going to start.
You can find tension easily with the resolution, I guess.
Why?
No, I think
You take that back now. Holy shit, he's taking it back. Why? My son.
Because it has such a multi-meter
How many of those are in free body diagram at D? 2. What are they? The 2 tensions. How many equations do you have? 2. Can I solve for 2 unknowns with 2 equations?
Yes.
Perfect. How many unknowns are in B? 3. I got the tension TB, I got the TBA, and I got that stupid angle theta. That's 3 unknowns. How many equations? 2. Can I solve for everything? Nope. And that's why D is the optimal place to start writing equations. So that's what I'm going to do. Sum forces in the x equals 0, positive to the right. Please note, I always write the equation I'm working with, and I know what the sense is for positiveness. To the right. So anything going to the left has got to bear a negative on it. Now, when you break this down to the components, remember, you must obey the parallelogram rule. So this has an x this way and a y that way. This has an x this way and a y that way. Correct? Notice, head to tail, head to tail. Perfect. So now I'm going to say T dB cosine 45 minus T dE cosine 30 equals 0. Or T dB is equal to 1.224 TdE. Didn't give me an answer. That's okay. I know there's going to be an answer because there's 2 unknowns and I have 2 equations. I'm going to get answers. The first equation didn't give me anything other than a relationship, which is fine. I'm okay with that. Sum forces in the y equals 0, positive upward. T dB sine 45 plus TdE sine 30 minus 300 equals 0. Or 0.707 TdB plus 0.5 TdE must in essence equal 300. What I've established is 2 equations with 2 unknowns. Method of substitution that you learned probably back in 8th grade. I'm going to take this and I'm going to dump it into here. So take this value, dump into here. If I do, I'll have 1 equation with 1 unknown TdE solved. TdE comes out to 19.78. Take this, dump it back into here, TdB comes out to 69.01. All pounds. Everything in pounds. Yes? You with me? Sure. I'm going to move this to here, to 69.01. Agreed? Yes? All right. Sum forces in the x equals 0 here. Positive to the right. That says 241. That's another x. Remember, this is 45 here. minus 269.01 cosine 45 minus TBA sine theta equals 0. If I simplify, TBA sine theta will equal to 50.81. Equation 3. Some forces in the y equals 0, positive upwards. TBA cosine theta minus 269.01 sine 45 equals 0, or TBA cosine theta is equal to 190.19. Equation. And you sit there and say, dude, you didn't solve for TBA or cosine theta. Okay, that's okay, that's okay, that's okay. I'm going to take now this equation 3 divided by equation 4. TBA sine theta equals 50.81. Divide this by TBA cosine theta. Divide this by 190.19. Cancel the TBAs. Sine theta over cosine theta is? God bless you. Tan theta is equal to 0.2672. Theta is equal to tangent inverse of this number. Theta is equal to 14.96. Take it, dump it into here. TBA will come out 196.86 pounds. Done. Where are you going, my son? Yeah, no. Okay. Questions so far? Everybody good? Are you happy? He's happy. Are you happy? He's happy. I'm always happy. When I go to class, I'm at my happiest.
You enjoy solving these?
What's that?
You enjoy solving these? You enjoy solving these or not?
Do I enjoy solving these? I always like solving problems. One of my favorite things to do. But I'm always happy when I'm in class. I could have a shitty ass day, but I come to class, for some reason, a switch turns on and I'm much better. Everybody's got their own thing. This is my thing. Any questions before I move on? Huh? Let's move on. I'll come back to 34. I'm going to move on to page 35. I'm going to deal with pulleys. Can I borrow a pencil from somebody? What are you going to write? Okay, good. All right, pulleys. Just as a reminder, massless pulleys, frictionless pulleys, and inextensible cables. Now there's two ways. Two ways to solve the pulley problem. There's the long ass way, and there's the quick, easy way. I'm going to show you both. If you're doing the weight, you want to probably do it the long ass way. If there's no weight, then you should be doing this the quick, easy. So I'm going to show you both so that you have it in your system. For me to do both, I'm going to label these pulleys that you see as pulley A, pulley B, pulley C, and pulley D. And then I'm going to use my pencil here, and I'm going to draw not a circle, but a box around each one. Okay? Wherever my pencil box touched a line, which is representing a force, a tension, I'm going to draw this in a free body diagram. So notice it touched here, here, and here. It touched here, here, and here. It touched here, here, and here, and here. So, my long ass way starts by drawing free body diagrams of pulleys. Free body diagram A, which is pulley A. Here's the pulley. I've got a force that is going to the ceiling. I'm going to call that TA. And then I got forces here, right there, they're where the two dots are. Those I'm just going to call T and T. Listen, it does not matter what you call them. You can call them T1, T2, T3, T4, T5, T6, T7, whatever. It doesn't matter. Okay? You with me? I'm going to write the equation. Sum forces in the y equals 0, positive upward. TA minus T minus T equals 0, or TA equals 2T. That's 2T, bring it over to the other side, becomes TA equals 2T. All right, that's equation 1. Free body diagram B. What do I see? Well, I see a cable from here, from B going to C. Yes? I'm going to call that T2. Again, doesn't matter what you call it. This cable right here is the same as what I had before in A. So that's T. And I know because I have frictionless, that's going to be what? T. So I basically have T, T, and I got a cable here that's going to the block, we'll call that TB. I think of it as tension going to block, TB. All right? So, sum forces in the y equals 0, positive up. T2 plus T plus T minus TB equals 0. Or T2 plus 2T minus TB equals 0. That's equation 2. I ain't doing anything fancy, trust me. Free body diagram C. Here's another pulley. I got a cable going to the ceiling. I'm going to call that TC. I got a cable here. That's what? T2. So write it in. T2. That's got to be T2. On either side of the cable, of the pulley, you have the same value for the cable. Sum forces in the y equals 0, positive up. TC minus T2 minus T2 equals 0, or TC equals 2T2. Equation 3. Wonderful. Next. Free body diagram D. I have a pulley. This is P. This I've already called T. And I should have a cable that's going to C. That cable tension is T2. Sum forces in the y equals 0, positive upward. T2 minus T minus P equals 0. That's equation 4. Have I done all the pulleys? A, B, C, D. Yep. What's left is this block. So I'm gonna turn around and do the block. It touched here, it touched there, I'm gonna show those. Free body diagram, block. $500 down, but here, this cable tension is, what is that? That's T. What's this cable tension? TB. Some forces in the Y equals 0, positive up. T plus TB must equal to basically 500. Or, in essence, TA plus TB minus 500 equals 0, same thing as saying equal to 500. Agreed? Who's not with me? Now, when you have such an extensive list of variables, all right, my thing to you would be, hey, make a list before you start going nuts on solving the equation that you've written. Make the damn list of the unknowns. Here comes my list. Unknowns. You ready? TA, T, T2, TB, TC, counted, P. That's 2, 4, 6. 6 unknowns. There are 5 equations. I am down 1 equation. Don't you dare solve anything because you're going to wow.
Why is it T2 or something?
By what?
Why is it T2 or something?
By what?
T2.
What about T2?
Was it,
You mean this one right here?
yeah, all of
That comes from here, which comes from pulley C. What did I call the cables coming off of C? T2, T2. Well, that's coming down to D, right? So that's T2 coming down to D. Can I answer your question? Yes. Yeah. Yep. So what's missing here? You can spin your wheels, go round and round and round. You ain't solving this because there's too many unknowns and not enough equations. What's the equation that's missing? It's pretty obvious. What's the equation that's missing? Well, look at this guy. What do we say on either side of the pulley? They have to have the same value. So the missing equation is P equals T. That's equation 6. Now you can solve and get an answer. If you solve and get an answer, you'll find that T equals 100 pounds. T equals 100 pounds. That's it. All right. Now I'm going to do what I call the P method, the quick, easy way. I want to get rid of all these lines that I've drawn so you can see a little better. And I'm going to blow this baby up. Oh, before I blow it up, is everybody okay with this?
Where did you get equation 6?
Huh?
Where did you get equation 6 from?
Where did I pulled it out of thin air. P equals 6. Where do you think I brought it from?
I just don't know what the P represents.
Go back to the original diagram. There's P. Right? P is what you're pulling to hold it in place. What's on the other side of that cable?
P is not equal.
But they have to be equal because it's frictionless pulleys, one side has to have the same value.
Thank you.
All right,
Where'd you get T equals 100 from?
huh?
Where'd you get T equals 100 from?
Solve 6 equations, 6 unknowns. It sucks. That's why it's a pain in the ass doing it the long way. Now I want to show you the short way. The short way is going to go quick, so if you're not paying attention, pay attention for about 15 seconds. Okay, let's make it 20 seconds. Then you can go back to sleep. How can you sleep in my class? I'm so damn loud. I don't understand how people can sleep in my class. Like, I don't stand still. I'm constantly, by the way, have you noticed I'm constantly moving? Why do you think that is? I'm nervous. No. I'm getting my cardio in. Yes, I gotta get my steps in. No! Because as I move, your eyes are constantly shifting left, shifting right, shifting left, shifting right. Because if I stay stationary, your eyes won't move. And if your eyes don't move, here comes the nodding away. Done. Especially if you had lunch before this class. How many had lunch before the class? You'd be the first ones to sleep. So have you noticed I don't stand still? That's to keep your eyes moving on me. Second, you'll hear me go up in volume and go down in volume. Why? Again, to keep you awake, to keep you with me. Right? Then all of a sudden I pick on somebody. Hey, carpenter. And everybody goes, ooh, he's going to pick on carpenter. So now you're thinking about what's going to ask carpenter. Now hopefully you stay awake a little longer. Now you isolate this. You can see I have a P, I have a 4P, and I have a 500. Some forces in the Y equal 0 positive up. P plus 4P must equal to 500. P must equal to 100. Same damn answer, but took me about 20 seconds. Did everybody see that? Oh shit, that was quick. Yep. That is what I call the P method. Did everybody get that? Now, you want to practice pulleys, I suggest you go to chapter 6. Midway in the chapter, it talks about frames and machines. A pulley is a machine. What do we mean by machine? It's not gas powered. A machine is anything that gives us a mechanical advantage. And pulleys give us a mechanical advantage. I don't need to go to the gym and become a he-man. All I need is for you to give me pulleys, cables, and I can lift anything you want me to. By arranging the pulleys and cables in such a way, I can lift way more than you could ever think about lifting by going to the gym. Yes? How did I get what? Are you talking about here?
Yeah.
Well, on either side of the pulley, they have to have the same value. So if this is P, that has to be P. If this is P, that has to be P. If this is P, that has to be P. Right? On either side of the cable, it's got to be P, P, P. Yes?
Can you zoom in on that?
I can, just for you.
Thank you.
Since, did you say please?
Please.
Yeah, you're welcome. There you go. Is that zoomed in enough? Or should I zoom in some more? Pretty good? Okay, there's my PPP. Let's go P. Whose chant is that in college? Let's go P. When I heard that, I cracked up. I was like, what? That's your chant? The school is called Austin P. I believe it's in Tennessee. And their chant I went to a basketball game and their chant was, "Let's go Pete." I'm thinking to myself, do you understand what you're really saying? But anyway, now, if I were to have weight available, I would just add W here, in which case I would have minus W. Oh, yeah. Yeah. I forgot. Steve did. But she asked me to. So if I had a weight here, I'd just add this to my equation. If I have a weight here, I'd add minus W here. If I had a weight here, I'd add a minus W there. So that's how I can take into account weight. And it's not so easy to do the P method when you got weights. When you don't have weights, it's a piece of cake. So I told you this problem here was an old test question. Watch. Start there. Everybody see that? So I'm going to come in and say, all right, this is P. Well, that's P, that's P, that's P, that is P, that's P. So coming down here, I have P, P, P. What's here? 3P. Coming around here, that is 3P. Coming around here, that's 3P. So I got 3P, 3P, 3P. That totals a 9 P's. 9 P's must equal to 1350. What's P? So 1350 divided by 9 is how much? How much? 150. So all this bullshit can now go away. I don't care about it. I'm going to put 150 right there coming to this pole. This now I'm going to ignore. Forget it even exists. All I want to do is put 150 there. Now that's gone. That's gone. Goodbye. That's how quickly you can do the problem. The 150 is no longer, the pulley system is no longer useful. I can just ignore it now. I got what I wanted, which is the force going to the hole. Okay? And that's how quickly you can do these problems. Is it time to go? Hey, you woke up. 3D, alpha, beta, gamma, and double projection. So you should expect that as a problem on the next quiz. See you later.